casual. We're about 10 minutes in, so I figure we'll go ahead and get started so that we don't keep y'all longer than we promised. But there may be a few other people kind of jumping in through the time. We're going to keep it super duper informal. And I should start, I think I've met everybody already, but Jessica Brown, I work with the University of Georgia's Marine Extension and Georgia Sea Grant. And my primary role there is for helping communities with making better informed decisions. And most of that is around flooding and water quality because my background is a water resources engineer. And so kind of the linkages for the topics today, but certainly wanted to thank Extension for allowing us to be in this space, and we're really excited because Mr. Aubry Shirley is going to talk a little bit about some of the resources that they have and give him a chance to say hello and give a little background. And then also, as part of the workshop today, Mr. Keith Jackson joining us as part of the larger effort that's surrounding the workshops. But since it's a small group and we're going to be informal and chill, I think most everybody's already kind of shook hands and done introductions. But are y'all okay with we like go around the room and say a little bit of something and hey and how are you and all that? Okay, cool. Who wants to start? Ms. Jackie, you want to start?
Hi, I'm Jacqueline Jones, leader of Reidsville, Georgia Community Floods. I'm under the umbrella of Anthropocene Alliance, A2 for short, because I know that's a mouthful. And me and Mr. Keefe are affiliated with Anthropocene Alliance. Yeah.
My name is Aubry Shirley. I'm one of the extension agents here. I've been here since almost 8 years now. I just do all kinds of stuff, crops, lawns, ponds, whatever you need. I give you my car, so feel free to call me.
Okay. Stephen Lewis, so I'm with the Army Corps of Engineers out of the Savannah District. I'm a planner.
I'm Cersei. I'm with the Southeastern Technical College GED program.
I'm Keith Jackson, Community Outreach Coordinator for Reidsville, and I'm under the umbrella, I'm under Ms. Jackie's umbrella, Anthropocene Alliance, A2, and happy to be a part of all of this. And it's been a fun ride, and I'm hoping to make the whole journey and see it all through the end. Glad to be here today.
My name is Patty, and I'm with the chamber, but I really wanted to come and check out some of the other things that y'all were showing today. So,
I'm Glenda Cowart. I live in Collins, and I'm with the chamber also, but I try to attend all these, so if anything that happens in Ridgeville that I might can take back to Collins, that's what I want to do.
Love that. And yes, we can be a resource for helping get things in Collins too. Looking forward to doing that. Well, y'all probably already figured it out, but I am perfectly fine if you want to stop in the middle of this, have a question, need to pause. Please feel free, but we do have a little bit of information. Before I get too far, I'm not going to get anywhere with that. But you've already heard us mention the organization Anthropocene Alliance, and I thought it would be really helpful to have a little bit of background or context for some of the other work that's been going on in the area, and also some of the funding resources that have gone to support this particular workshop. So we're going to talk a little bit about that, and then a lot of folks can associate or get their hands wrapped around the impacts of flooding and water quality, but I think it's always I always like to introduce stormwater and sort of the angle that we're coming at from stormwater management. And then we're going to talk about things that are specific to yards, because a lot of the project work before now has really focused at a much larger level, and so the resources that hopefully we'll get through today are more of what you can do in your own landscape. And we're going to spend a fair amount of time talking about rain gardens, not only because they're pretty and some of my favorite practices, but we've got some really great resources that I think will be useful and then just kind of wrap up with where we're headed. So, mentioned this group, A2, and they are a fantastic convener of peoples. They linked up with Miss Jackie and a few others several years ago in an effort to address a very large flooding problem in this area. And they have been very successful in bringing together a group of experts with Sherwood Engineering and their partner Biohabitat, as well as local expertise and some larger, more regional entities like the University of Georgia, as well as the Riverkeeper, to combine some resources that are hopefully all going to come together in a restorative landscapes plan for this area. And one of the big projects that we're kind of coming to a close for some of that initial funding, but there's going to be a guidance document speaking to all of their assessments, and as well as plans to link that to future funding. And so that's kind of the exciting part of those next steps. And so I think you'll start to hear a little bit more about things like stormwater ponds and bioretention and these large scale kind of means for addressing stormwater. But like I said, the intention today is also to provide some of that context so folks can address things in their own properties and in their own neighborhoods. Because we all have a part, right? So one of the big pieces as part of that plan, and I'm totally, actually the credit is slipped off the slide on the bottom, but these are graphics from colleagues with Sherwood and Biohabitat. But one of the big things that they have found as part of their assessment is over time, all of the infrastructure, which some of that is pipe, but a lot of that is your street side canals and ditches that we've used to manage rainwater, has become disconnected and fragmented for a variety of reasons. But the intention with that planning document, as well as some of those larger efforts, is to move that disconnection back to something that looks a little bit more connected. And utilizing relatively new science. I was actually talking with Aubry kind of early on. A lot of the science in nature-based solutions has actually been around in our lifetime, more or less. And so that's kind of the overall approach, and certainly want to connect back to that larger effort. My clicker does not like me standing up there. But like I said, the purpose of today is to really dive into resources that are helpful on an individual landscape. So I think it's always helpful to kind of go back to an original definition. And so I love it because when I was first explaining what I do to my grandmother, she was like, this is what you need to say. And so I credit her with this, but stormwater is any time that we have precipitation. And in our part of the world, most of the time that is rain. We don't deal with a lot of sleet and snow, and hope that we don't have that opportunity anytime soon. But any type of precipitation that can become runoff because it falls on a surface that can't absorb it. So think about parking lots, rooftops, any sort of impervious surface that can't soak in the water. That precipitation can become stormwater. And as you might imagine, because we've all experienced it, there's two major challenges with stormwater that we're having to deal with. One is the quantity issue. And these are kind of, well, with the exception of that one, all the homes flooded. Pictures of the area. This is Highway 80. If you've been out to Tybee, this is one that we see in the papers all around, or anytime we get flooding, they love to flash up Highway 80. But many of our streets, you see abandoned cars in stormwater ponding and flooding. It's a problem throughout all of Georgia, and particularly kind of the lower coastal plain of Georgia. So the quantity side of it is really important, but also as stormwater moves across the landscape, it picks up a class of what managers like to refer to as non-point source pollutants. So when we think about those, we're thinking about sediment or soils, fertilizers and nutrients, pathogens that could be from wildlife or pets. And when when we don't pick up after when we don't pick up pet waste. So all of these types of pollutants that can actually get in that stormwater and then make its way to a larger water body. So we've got a water quantity issue and a water quality issue as part of it. And I mentioned that the approach with a lot of the work thus far is to really look at those, a new-ish, innovative way of addressing using nature-based solutions. Or in the stormwater world, oftentimes we're calling those green infrastructure solutions. And on the screen now are some of those larger scale things that you might see eventually around town, but if we look at a much bigger application, things like bioretention, which is kind of the big sister of rain gardens, which we're going to talk a lot about. But you may also see pervious pavements, that piece of pervious concrete in the center. It was kind of moving through everything that looks kind of like a gray Rice Krispie treat. It's not, it's concrete. But these are all practices that mimic how nature handles water. So we're using plants, soils, and built materials that manage water like it once was prior to development. And there's a whole suite of benefits. I'm not going to read those, but depending on folks' motivations, if you're looking to encourage this practice or these practices, obviously people have different motivating factors. For some folks, it's just because they're pretty. They're green. The plants are much more life-giving than concrete asphalt parking lots. For others, it's a way to create jobs. It's workforce development. It's an opportunity to engage in local community. So they provide a lot of benefits, and they do move us toward that more connected landscape. Aha! There we go. So I'll pause there. Questions, comments, anything that was like really super duper confusing? That's my intro to stormwater real quick. But, all right, well, let's drill down a little bit more and think about water in your own yard. When it rains, where does it go?
It's washing me down the hill.
Carrying you all the way down the hill?
Yes, ma'am. We're on a hill,
Okay.
and the water from my husband's shop runs off the roof onto the platform we got here. And we're on the clay hill, and when it hits there, it washes all the way down till it levels out.
Gives you an orange waterfall.
And so far, we haven't been able to stop it. We had to actually replace the porch part, or deck part, because the water undermined it, and it was fixing to blow out on us.
Oh, wow.
So it's washing me down the hill.
It is washing you down the hill. Wow. Well, maybe, hopefully we'll be talking about some things that might keep you on the hill, or at least keep you further up the hill. Other, as you think about water in the yard? Well, oftentimes, we do get a lot of benefits from precipitation. We get prettier lawns, we get prettier landscapes, but that's not necessarily the things that we think about. We think about all the nuisance that it causes. And so I'm going to step through, I think, 3 different practices. Yeah, 3 or 4. But one of the first steps in addressing all of that is to actually take a look at it. Keith and I were talking about it earlier today. I'm surprised at how many of our downspouts, if you have downspouts, a lot of folks near me do not, but many of those downspouts that are directly connected with a pipe out to the storm drain in the street. You never see it, kind of moves underground. And the challenges that that's bringing with the volume that's in that system. Or there's instances like this, where the downspout runs directly to the driveway, and the driveway is directly connected to the street, and there's never an opportunity for the water to actually make it back into the ground, causing a much larger ponding issue further up. So one of the first things that I always encourage folks to do is actually get out and play in it and take a look at where the water is going. How many folks have downspouts? Okay, couple. If you do, this is actually a really cost-effective and pretty simple solution. This downspout disconnector at a big box store like Lowe's or Home Depot might set you back $10 max, but a lot of them are flexible extensions so that instead of dumping all of that on your driveway and further running it down the road, moving it to, in our case later on, a rain garden, or even just back over to a really healthy lawn, actually allows that water to get back into the ground, be filtered out, and actually recharge groundwater versus being dumped right into the system that
So some of that
contributes to
brown
flood.
thing right there is what you got at Lowe's and you can move it around?
Yep. There's a couple of different fancy ones, like the one in the top right, and the clicker doesn't show on the television, and I'm short, but the one in the top right is actually just an additional piece of gutter. But so the right hand side are gutter extensions. The brown on the top left is the most common, and right now that's going to run you about $4.53 because I just bought one last week.
So
At
they're not hard to
Lowe's.
put on? See, these other ones right here, my problem is they broke, so they're hard to put back on, but something
Yes.
that would slide on would be nice.
Exactly. And so that one, and the other fun thing is it actually looks like my 3-year-old's toys. Like it's flexible, so you can
Maybe
figure
not.
out where it goes, and they even make kind of like a stake so that you can make sure it stays in that way.
Okay.
But yeah, really simple, kind of cost-effective solution for kind of redirecting some of that rainfall. And like I said, really a lot of folks are often surprised when they get out and take a look at it because their contributions downspout to the driveway are actually compounding a lot of the flood problem that we can address. Another solution that I hear a lot of folks talk about when we are looking at our local landscape is the addition of a rain barrel. And not everybody's rain barrel looks like this really fancy, pretty one. This was part of an artist project that I was involved in several years ago, so keep it up there in perpetuity because it's just so fun. And not everybody's has a fancy rain chain coming from their house either. Mine looks like a glorified trash can, I'm not gonna lie to you, but these are smaller scale versions of those large cisterns that you see. And so rainwater harvesting is a practice that's been around since the beginning of time. But placing one of these in your landscape, these hold about 50 to 60 gallons of water, fill up pretty quickly in our afternoon rainstorm, and can be a great addition to offset some of the irrigation. And there again, repurposing that water, keeping it from flooding out areas that you don't necessarily want to have it. So, and if you're really lazy like me, I think you were talking about before, you can easily put a soaker hose on the bottom of this and run it out into the flower bed, and then you get free watering for at least a little bit. I actually was doing the math on the way up here in my head. Reidsville gets about 50 inches of rain a year. And so if you were to have one of those, on average, you could save about $86 a year on your water bill if you're using potable water to water a landscape. But you could manage about a little over 23,000 gallons of water with just that little barrel. It's a lot of water on every year. The tricky part about rain barrels though is you gotta use the water.
Yeah,
Yes, sir.
I was gonna say, me and my neighbor were just discussing rain barrels. I came up, I was looking for a burn barrel for my uncle, and my neighbor was talking about, when we was pricing barrels, and he saw the burn barrels ran from like $10 to $20. And at the same time, those water barrels, rain barrels running about the same price. So in extensive.
Wow.
I mean, there are
Yeah.
tons of them in this area. I mean, most of them that we found was right in this area here, about a meter, all over. And that's why he irrigates his lawn, and he wants to put one, because he got flower beds all around his house, and he got, tomatoes growing on the side of the house also, and he wants to use that for that. That way, he'll save a lot of water.
Cool.
Those have your veggies too.
Hmm?
They say it helps the vegetable too.
Yeah.
Is that not true, the way from the city water and the rainwater?
There's chlorine in the city water, but I wouldn't say it gets taken up real fast when it hits the soil.
Does it?
Yeah, I've used city water in the garden. I mean, you'd have to put a lot of chlorine to mess up the soil.
Okay. It was just something that somebody mentioned about the fact of the things in it. It's probably because they're more organic though.
I mean,
They're
yeah,
working on the organic stuff, so.
But that was a question that came up, is using the rainwater coming off the roof itself, you know, someone was worried that it might get contaminated, you know.
Yep. Well, there's a couple of really interesting research studies, and I can get you a copy of it if you're interested, or if you suffer from insomnia. It'd be a great read. No, some really interesting research coming up out of like the New Jersey, New York area that did a big study on that. If you have metal roofing, or if you have a moss problem, and you can correct me, is it mossicide? Whatever, there's a product that you would use to remove moss from your rooftop, and if you treat your rooftop with that, then you can get that leachate continuing in your rain barrel. But on a traditional, not maintained rooftop, they didn't show any sort of pollutants that would be harmful for ingestion. Now, I water with my rain barrel. Would I go out and pick the tomato and eat it in my yard like I have other times? Maybe not, but for another sink and should be fine. At least that's what the study was supporting. So, yeah, generally pretty safe for use. But I'm going to kind of zoom on through some of this information, help keep us on track, and certainly not cut Aubry's piece short. I saw lots of folks had resources that we put out back, which is great. You're going to see lots of this kind of sprinkled in through the presentation. But what is a rain garden? It is a shallow landscape depression, typically very small, less than a couple hundred square feet, that is vegetated. We like to support the use of native plants, but that captures, filters, and stores stormwater. This is one that was installed probably almost 15 years ago now. That is sobering. But you can see it's right next to the front stoop. No one would actually know that that's actually in a bowl, actually handling all the stormwater coming off the porch. It just looks a lot like the rest of the landscape that's there. But certainly is serving a purpose, intercepting kind of that line of water as it moves from the yard to the storm drain or to the nearest ditch. Similar to other green infrastructure, it provides a suite of benefits, and depending on what you care about, one may be more attractive than another. Lots of folks recently, we've been hearing a lot about pollinators and providing beneficial habitat. That's definitely something that rain gardens do. They do a great job with nutrient uptake, often offering lots of flowering plant opportunities, and can be really beautiful additions to the landscape. But in thinking about the challenges of stormwater with that flooding and water quality piece, they can also help get that water back into the ground and filter it, make it better for everybody too. So we'll point you to these resources. I apologize, I did not bring the actual sign. There is a link if you want to have an online copy. You all obviously have a paper copy. It does say rain gardens for coastal Georgia, and you are in the lower coastal plain, even though you're not next to the ocean. So everything is applicable, but I will say most all of this guide is a great reference throughout the state of Georgia. It's just that the plants that we're going to talk about are highly specific to this ecoregion. So once you start to get a little north of, say, Athens, they're not as, may or may not be as suitable. So, yeah, certainly feel free to take a look at those resources. Y'all have the skinny today, but there's also an older 2-hour webinar kind of talking through that guide as well. So a couple of things to think about in your landscape before I kick things over to Aubry, but we don't want to be looking at places that are already wet. And this is the number one thing that a lot of people struggle with when we talk about rain gardens. Now, if you have a wet spot, there is another residential practice that we're not talking about that could be appropriate, but the whole function of these is actually to get that water back into the ground and not create kind of a ponded situation. So these are going to stay wet for 2 to 3 days after a rain and slowly allow that water to get back into the ground, but is actually going to make it back into the ground and not create mosquito habitat, which nobody likes to deal with. Definitely not me. And so we want to look for locations that are not already ponded, but are kind of in those pinch points. So in between either the driveway or the rooftop, where you have that impervious surface, and wherever it's trying to get to go, that ditch, pipe, street. Anybody got a basement? We're not very popular in this part of the world.
I don't think you can.
Yeah, I was saying, usually when somebody raises their hand, I'm like, really? How'd you get by that? But certainly if you have a basement, we want to be 10 feet away, but we don't want these right up to the foundation of the property, right? Because we're looking at holding water. So we don't want to create any sort of structural problems to outbuildings, houses, other locations. We want to kind of move those 2 to 4 feet away because we are going to be concentrating water there. Want to stay out of the drip line of trees. So if you're thinking about large tree systems, we certainly don't want to impact their roots. And a good rule of thumb is wherever you can look up and see leaves, there's probably roots under your feet. And that also makes it a real big pain to dig one of these out and create that little bowl. So really good advice to stay away from there. Be cautious about the slopes. But the last thing, and like I said, there's some more resources in there, kind of broadening this out. But we want to be mindful of utilities. There's actually free service that will come out and locate those for you. That's 811, and we can talk about that in more detail. But you also want to know something about the soils that are underneath. And so, really super excited because most of the time when I get this up, I'm like, check out our friends at Extension and go to this resource. And guess what? We have our friends here. They actually are hosting it. So I'm going to switch things over and let Aubry talk about soils.
Okay. So, thank you, Jessica. Thank y'all. I appreciate her coming. So I'm hoping there's just a lot to talk about in soils, okay? Soils are very, you look at some soils, you say, hey, that's some dirt, that's good and all. And I didn't really know how to start this talk. So I gave a similar talk, I don't know, a few years ago to the Reidsville Garden Club about soils, and I call it the wonderful world of soils. And so I'm probably going to talk about more stuff that y'all may want to know, but I think it's very interesting stuff because soils are very complex. There's, right under our feet, there's a lot of stuff going on. It's not just I'm on that concrete. There's a lot of stuff going on underneath us. And so all soils, there's several factors in considering how a soil is formed. So you've got parent material, you've got your climate, you have living organisms, landscaping position, and time. So what would a parent material, do y'all know what parent material is? What would you think parent material is? Well, the whole theory is it's from rocks. So I watched a documentary, I was a long time ago, and they were talking about that there were some guys, I think they were geologists, and they were looking at a lot of Roman architecture. So the Roman architecture nobody had been around for thousands of years, and they saw trees and stuff growing on top of buildings and in the aqueducts. And they got them thinking, what is forming? How is this forming? How is soil forming here? Nobody put it there. And so that got the idea. And a lot of this soil science about all these formed this theory of soil genesis, or what they call pedology. formed from the Russians. The Russians started all this whole science, and so they got this, that's how this all came about. So the parent material is rocks, so any of the bedrock. So different parent material is going to form different types of soils, okay? And also with that, you have climate. So let's say you have the same parent material here as you would, in the mountains, that's true, but you have different climates. You have subtropical, tropical, you have desert, you have wetlands, you have areas that freeze, Alaska, think of that, and then the Arctic and stuff like that. So that is what's one thing that helps form your soils, different soils, and then you have living organisms. What organisms live in there, that help break down the minerals. You also have landscape positions like you talked about. So that all these are sort of, they're all sort of integrated into one. So what position? Are you always going to be wet? The soil's going to be different there. So let's think if you have a mucky soil. A lot of clays get translocated there and they sort of stay there, okay? That's how you have that. So a good example of that here, are y'all familiar with the Hopi sand dunes? Y'all know about the sand dunes, okay? The sand dunes are a very unique ecosystem in and of themselves. So the state soil here is a Tifton soil. Y'all familiar with the Tifton soil? Well, everybody says the prison got the best soil. That's where the prison farm is. They got the Tifton soil. And so if you go to the Hopi sand dunes, that's like literally just sand that's like 90 to 100 feet deep, okay? That was formed, the whole thing behind that is that was formed by wind-blown sand off the Hopi, So if you go on the sand dunes, it goes all the way to Swainsboro, follows the Hopi River, and it just looks like a desert because that's a different soil type. That's how these soils are formed. There's that example is just there to give you like all the different factors that go into soils. So here is how I found this. This was a good illustration. So over time, it's probably millions of years. So you have bedrock. The bedrock gets rain in it. There's maybe a crack. So that crack forms, rain gets in there, it starts eroding it away. And as the cracks gets bigger and bigger, you get smaller aggregates. And as the aggregate gets smaller, more surface area. So there's more to break down. As the surface area gets smaller and smaller, you start forming your horizons. And so that's how we get different soil horizons. Are y'all familiar with what a soil horizon is? Okay, well, I'm about to talk about that too. So that is the genesis of soils right there. That's sort of the main, that's how the theory goes. And so, and with all that being said, do y'all know the difference between dirt and soil? No? Okay, well that's the definition, that's what I made up. So I define soil as something that's useful in a garden situation or a farming situation or any kind of landscape, trees, flowers, shrubs. I define dirt as something that, you put into a hole. I fill out the hole with dirt. I put the dirt under my, you build a foundation of a house. I use dirt. I don't really care what kind of dirt it is. Just put dirt there. There's underneath me right here is dirt. Okay, they fill this in. This is dirt. That's how I define. So I like to talk about, I always refer to it as soil because that is, to me, soil is a living organism. And it has both inorganic, meaning like rocks, minerals, nutrients, has air, water, and worms. You have nematodes, you have other microorganisms that live there. You have mycorrhizal fungi that help with roots. There's a bunch of stuff in the soil. So if you just have a handful of soil, there's a lot of stuff living in that soil that you just may not think about. And so all of these soils, there are all these classifications, and every country does a little different. The United States has a way of doing it, Europe has a way of doing it, Russia has a way of doing it. And so they're put into, you can think of soils as being grouped in similar fashion as how you would group the animal kingdom or the plant kingdom. So you have orders, suborders, great groups, subgroups, families, and finally you have soil series. And the soil series is probably what you would, that's at the most local level. So, if we talk about a Tifton soil here, I'm from North Georgia, but I know Tifton soil. I don't really know what series I had up there. Alabama has like a Dothan soil. That's a common soil that's down in Southwest Georgia, also around here as well. And so a good website, I'm hoping this works. You alluded to this in the other one, is the NRCS website here. Let me see.
No love.
Can I end the show? Can I do that right there?
Sure.
Oh, sorry, y'all. Okay. I've used this website a lot. It's a very good website. I wanted to do it in real time because it can be very cumbersome.
Click on the blue. Yeah, there you go.
Okay. And this is just sort of goes over the 12 orders of the soils, okay? And our soil type around here it's the next slide over, it's called iltal soils, and they're highly weathered. We have a lot of old soils around here. The highly weathered means that basically all the clay has been translocated below. So out west, are y'all familiar with any of like the bentonites or the clays that you use for, putting in a well casing? Those are called expansive clays. They're 2-to-1s. And that means that when they have water, they expand very much and they contract. So you have these large cracks and large contractions, and it expansive and it contracts very much so. And so those are younger soils than us because the clay's on top of the ground a lot. And so these ultra soils all over the southeast from, well, not so much Florida, but from Alabama, Texas, all the way up to North Carolina, is highly weathered. So you can go here. I'm not going to go over all this, but you can go here and get as much information about the different orders that you want that you can ever want to know. Okay, and so that one. Okay. Let's go forward. Okay, and this is just a graphic. And as you can see, the orange soils. That's what I was talking about. Those are the highly weathered soils. And I don't know if you remember from high school, what areas around here? You have the mountains. So this side of the country it's been weathered a long time. We've had a lot of weathering, and that's why the soils are like they are. And so, can you tell me what's going on right here?
It's greener.
The Midwest. There's a really deep organic matters.
Oh.
Like 3 or 4 feet of organic matter here. And everybody says, well, in class they would always say, we got the best Canadian soil. Because during the Ice Age, how these soils formed here was during the Ice Age, all the ice, like mile and a half high ice sheet would move all the soil, and it stopped about right around in here, and it moved all the soil. So we got all their topsoil, and they didn't get left with a lot up in Canada. So that's the difference of the soils there. And I think y'all should go to these websites. They're very good. That's a very good graphic. It's very interesting to me.
What is the website?
That NRC, here, I can go back. If you what you can do is you can Google, you can NRCS, or you can look up the soil orders or 12 orders of soils in the United States.
But if you want, you got the cards and stuff, so you can always.
Yeah, I can tell you.
Tester.
Yeah, you can call me. I can help you get there. Yeah. But it's very interesting stuff. And so, going back to this, soil classifications as you go down to the series. And so from the series, as I talked about, you have different horizons. And so that series is even broken down further. So these are the main horizons of soils. You have your O horizon, which is organic matter. And so this is what you see on top of the ground. And there's different types of O horizons as well. I'm not going to get into all that, but there's different types. So you have some that are chunks of organic matter, like unbroken down leaves, and you have stuff that's actually broken down. And then underneath that, you have the A horizon, you have the E horizon, your subsoil level, which is your B, and these can all be broken down into different transition zones. You have your C, which is your parent rock. And I've never seen it around here, but when I went to school at UGA in Athens, if you dug down probably 60 inches, you could actually start seeing what they call saprolite. It's just basically rock that hasn't been fully decayed. And that will eventually become these horizons as well. That's the theory goes. This would be younger than this. It's less weathered. And of course, ultimately, red bedrock. I mean, you can definitely see that in the mountains for sure. And so, this is another good website too. And this is the Web Soil Survey. And what kind of soil type do you have? So if you're going to going back to the rain garden stuff, if you're going to do a rain garden, how do you know what soil you have? What's the main soil type you have? So what you can do is go here, the web soil survey, and I'll just take just a few minutes, I won't take too much time. This is, what's really neat about this is how accurate it is, because, you know, I don't know who went out and put this all in GIS or whatever they put it in, but it's very accurate. We built a house and put it on mine, and it's like, where the line is that's where it is. So you go here, and if you need help with this, I can help you out. You can come to my office or call me or whatever. So what you do, let's see. Let's just, I did Reidsville, for example. So you zoom in. Let's see. I don't want too much north. It's hard to see up here, y'all.
Right there.
You see Reidsville? I'm looking.
I see Glen, yes.
There's, okay, we'll just do it. There it is right there. Tulsa. Reidsville. That's what I'm going to do. Since we're talking about Reidsville, I'm in this area earlier today. Okay.
Wow, it's real specific.
So what you can do, you can zoom in on where you want to go, and then you see this area, AOI, that's area of interest. So if I want to go to area of interest, I just go here, wherever you want, I mean, where your house is, or it doesn't matter. So you click it. There it goes. And that's your area of interest. And what you can do from there, it's a lot different to look at. So then you can go to your soil map, you click it, and then it'll tell you what you have. So it separates it. So in this area you have OS. OS is osier loamy fine sand. Then you have the BOC, which is bona fide fine sand, bona fide. And then you click on that, and it'll tell you what you've got. It tells you, so your depth, so
Wow.
from 0 to 57 inches, you have fine sand. So let's say you wanted to put a rain garden or whatever you wanted to put in there, or you wanted to grow pecans. Well, you got a fine sand, so it's probably going to be very, water's going to flow through that pretty fast. So you may want to, oh, maybe I'll rethink that. I don't know. And so, and as you go down, sandy clay loam. So I mean, this is very, very deep sand. Almost 70 inches is what?
More than 6 feet.
More than 6 feet. So that's going to be very, very, you know, water will flow through that very fast. And so you can do this for any kind of soil. And so if you know, so I really like this. And so this osier. And so, okay, and that, like I told you before, you have your different horizons. So you have loamy fine sand there. You have another A horizon. And I don't, like I said, I don't know all the ZG, I don't know. Those are different horizons there. But yeah, you can do this with any slopes. Wherever you live, and if you're looking like what's going on here, it also goes over slopes, where how the slope is, because you can see this.
So how accurate is that?
Very.
Like if I did in my backyard?
You can do it. It's crazy how accurate it is.
Really?
Yes.
Hey, I got a question.
Yes.
Is there any correlation to, types of vegetation? I mean, like, just say, if I want to grow something in my yard, or somebody say, hey, I saw such and such plant in this area, in this yard, and if you look up the soil, like, no way, that plant won't grow in that soil.
Yeah, you can. Yeah, for sure. I mean, I know people that have put, you know, they'll put pecans will be growing and stuff in a really sandy area. And not that they can't grow there, but if you do put that there, you're gonna have to water a lot. Because I mean, like I said, the Ohoopee dunes, there's a lot of stuff that grows in there, but I mean, when you have a 50-year-old tree that's about this big around, you know, hey, it's gonna be hard to get something to grow. But I do love this website a lot. I've used it a lot. It's really nice because like you were saying, it helps you with your slopes, tells you where slopes are, how well drained it is, and you can also look up flooding zones too. I think you can do this to do flooding zones, and that's really helpful as well. Especially if you want to build a house or something, it'd be very nice to know where you're flooding, are you going to be prone to flooding here or there.
Well, now I can go see what kind of soil my cousin has in Collins. He got a banana tree growing beside his trailer, and it's actually edible bananas.
Yeah.
Yeah.
You can actually search an address, so you can do a box like Aubry was doing, but you can actually punch in an address and search it.
what's still survey, it's a great thing. And then, I showed this because I thought this is a very cool slide, and, you know, understanding, I mean, granted, this, well, you can't see this, but on the left-hand side, this is an extreme example of erosion, okay? I just put that there because this is what can happen and what did happen all over, you know, all over the southeast. If you see where gullies are, those gullies weren't just, you know, wasn't God making a gully, you know, humans had farmed the same thing over and over again. And this is, do y'all know where that's at? This is called the Little Grand Canyon. It's in Sumter, I got the next slide, it's in Sumter County. And it's, some of these gullies are 150 foot deep. So that's what can happen if you don't take care of your land. Not that, we're building a rain garden here, okay, this is not gonna happen. I just think it's important. And we've changed our whole, how we do agriculture. A lot of people do no-till, they do cover crops, and people do till, but they don't, you know, they do a lot different than they used to. Because where I'm from, there's gullies, they're not like this, but I mean, they're 20, 30 feet deep. Rock Eagle's the same way. If you go to Rock Eagle, there's gullies there too, and that's from just over farming. And so, where do we go from here? I do all this, I like to give the background, so what's the big deal, okay? You know, we're talking about rain gardens, but this can be for anything. And you're gonna get into areas and stuff, okay, so that's what I thought you know, how much water is gonna be coming off your roof? You know, what's the depth? How deep do you need this rain garden to be to collect the water? Where does it go anywhere? What's your fill material? And then for soil, we can talk about soil samples, but for a rain garden, I don't know if necessarily soil sample is gonna be that important, but for yards or any kind of flower beds, soil sampling is important because a lot of times I went out to people's yards and they're like, hey, what's going on with this? And I say this all the time, I'm like, have you taken a soil sample? I know that's like a cop-out, but I don't really know what else to say because I don't know what's going on unless I see something going on in the soil. Is your nutrients level low? Is your pH low? Is your pH too high? What's going on? So this is just an illustration of what you need to do or what you can do to soil sample. In UGA, you know, farmers will usually take, if they do grid sampling, they can probably do 2.5 acre grids, maybe 5 acre grids. For a homeowner, you know, you don't really need to do that because if usually your yard's about an acre, you can take 1 sample per acre. Or if you have a bad spot in your yard, you could take a bad spot and a good spot. I like to do more the merrier because when you take, let's say this green right here is 1 acre. You take that and you put it in a bag, right? You give me a bag, it's got this much soil. At the lab, they're going to mix that in a container about this big, and they're going to extract that much. So how much representation you're going to get. So I like to do more representation is the best. That way you sort of get a better idea of what the average is. So when you do sample, you want to do random around. So you'll just walk, you walk 5 feet here, 6 feet here. You do a zigzag all over the yard.
So you do it every 6 feet?
No, just however. You want to do 6 and you do 10, you walk 10 more feet, you walk 15 feet, just random.
Just random?
Just random. I mean, a lot of guys will go right here and they get a sample and they'll bring it to me. I'm like, well, that may be accurate, that may not be, I don't know. And so, you know, why is soil sampling important? One of the main things that soil sampling is important is because the main driver of any kind of nutrient uptake is your pH, okay? Plants like, most plants, for the exception of like blueberries that really love acidic soils or azaleas, you know, that they can live in like 4.5 to 5.5, that's what they like. Most plants live about 6 to 6.5. Go ahead.
Yeah, it does. I mean, like, in an area like Jefferson County, which I also spent part of my childhood in, they have a lot of clay.
Mm-hmm.
You know, they have that clay up there that they actually eat.
Yeah, midnight, yeah.
Okay.
Not midnight.
And a lot of the yards, is clay just, I mean, everywhere.
Yeah.
Like the whole yard almost. Doesn't matter when you talk about a rain garden, whether it's sand or clay.
She's going. I didn't know. Yeah, she's going to talk about that.
Don't steal my thunder yet, Keith.
She's got good stuff. That's why I talked about it, but I was just gonna.
I know you talked about
Yeah,
rain garden. I didn't know if you were done with it.
Nope, not yet.
Okay.
So,
Well, yeah, not yet.
so most plants like 6.5 to 7 or 6 to 7. That's when you want. And this graph, this illustration sort of shows that. So as you can see the bigger the bar, that's the availability of the nutrients. Just a representation. So as you can see, from 6 to 7, all the way up, nitrogen is available up there, but really high pHs. But for the most part, 6.5 to 7 is your sweet spot, okay? As you can see, your iron gets lower as you get higher, your manganese as well. Then your NP and K, or nitrogen, phosphorus, potassium, that's your 3 major elements that what we use, except for, of course, under carbon and hydrogen, but we don't, they have those, you know. NP and K are the most important. So that's why you want to check your pH. A lot of times, soils will be fine, they just, the pH is off, and once you bring the pH where it needs to be, your plants will be better off. And so, how many of y'all have ever taken a soil sample, or brought a soil sample by our office? You've, okay, you've, okay. And this is, I didn't want to put the person's name, but this is just a sample of, man, I forgot about this. This is what you're going to get when you get a sample back from us, okay? And if you have trouble, can y'all see that? Try to make this big. It's okay. Sorry, we are a little farther back, but what it does is it gives you, basically it has a line. It has, line, it has needed or sufficient or not sufficient. And so you have your, and they're never going to give you a nitrogen recommendation, because nitrogen is, we always assume it's going to be leached out. It's the most leachable of all the nutrients that we have. It leaches it, you put it in, it doesn't stay. K is less leachable, and phosphorus basically bounds to the soil particles. It doesn't go anywhere. So if you have a sufficient phosphorus, you probably don't have to add it. But it also gives a breakdown of what you need. And so it says recommended pH 6 to 6.5, and it gives you all these instructions. Broadcast 5 pounds of, this is 3400, and you can just follow those recommendations. And if you have any questions, and if you do a soil sample with us or with any extension office, that you can call them, they'll help you what to do. And for the most part, if you have, for homeowners, if you have a bag of 10-10-10, that's probably going to do what you need to do. It has everything you need in it. That's what I do. A lot of times, I don't take soil samples, okay, sometimes. I shouldn't say that, but I don't. Because I was like, well, I got some lime, I'll throw it out. Yeah, I know. But I don't. But I have 10-10-10, I'll throw it out. And if my pH gets, I'll do a check for pH. If it gets low, I'll put some lime out there. This is what you'll get with a soil sample from us. This is the breakdown. And we'll email it to you or mail it to you, whatever you want it, however you want it. And so, and Jessica wanted me to talk a little bit about water testing as well. I do have a lot of people that get their water tested. I don't know, how many of y'all are on city water? Most people. Well, then I'm on city water too. You don't really need to test city water. Okay, city water, they have their own test by the EPD and the EPA. They have their standards. And if something goes wrong with their water, they'll let you know. They'll say boil your water, or don't drink your water. But if you're on a well, I recommend, and UGA recommends, at least once a year, testing your water. And the most popular of the water samples that we have is the W1 and the W35, and I should put biological, but W1 is sort of for your minerals and maybe your other elements, like your heavy metals. Your W35 is your E. coli and your tolucoliform. And so this is just another readout of what you'll get. It's not showing up. I keep doing that and it never works. And so as you can see, you have the top. Can y'all read the top and the bottom? Can you read? So the top is tolucoliform, and it has your units. NPN stands for most probable number, and that's just a statistical way that they sort of test the way they take your water. So if you bring a water sample to us, it's in a bottle about this big, and it has sodium thiosulfate in it, which counteracts the chlorine if you have chlorine in your water. They take it, they incubate it in this incubator, and they fill it up this little thing about this big, and it has all these little square vials in it. They incubate it at like 40 degrees C, maybe 45, I think 45, something like that. And they run it through this, put it in the incubator, and then they run it through a light. And if anything fluoresces or lights up, you have coliform. And if it turns purple, you have E. coli. And that's how they get those numbers. And you'll know, and I've got the next slide here, if anything comes back not normal, there'll be a red, there'll be like a big red, like this is not acceptable. So you'll know, it's like, is this acceptable? Can I drink this or not? You'll know. And this is just another water sample. This is a W1. And do any of y'all have any ponds? Ponds? I tell a lot of people to run the W1 on ponds as well, because it's a good thing. It tells your water hardness, and it tells you if you need the lime or not. So it's a good way to tell if your pond's okay. But you can run this one. But when you do this one, it gives you all these different parameters. You have aluminum, boron, calcium, chromium, copper, and this is just sort of the tip of the iceberg, if you will. We can run, I think, a total of 50 different chemicals if you wanted to, but it gets very expensive very fast. because I think there's another test. It's $40 for the chemical, then it's $10 for every element you want to test. But if you wanted to, we've tried to drill down with some people to see what's going on. But yeah, we can do that.
So are you the one that you come to, like if you're building a new home and you have to have a well and you want it tested?
We can do that so sometimes we get FHA loans and VA loans, and they want a third party.
Right.
And I'm the third party. I'm like, well, I'm not licensed to pull a sample. I will pull a sample, but it's sort of awkward because sometimes they want me to do so this sample right here, the W1 is what we call the first draw,
Right.
okay? The first draw means that you have to close your water off between 6 and 12 hours, okay? And if you, what W1 tests for, other than the W35, is actually sort of testing your water, but also what's in your pipes. Let's say you have old pipes and there may be leaching, any of these things, you want to know that, okay? So that's, with a VA loan and stuff, they'll want to know that kind of thing, and so they'll want a third party. If you're building a house with a well, you can go to Lance at the environmental. He'll pull a sample for the W35, the E. coli. He'll pull a sample for you, or I can pull a sample for you. I don't mind. But sometimes they, UGA lab is a certified lab to do like VA and FHA loans and stuff like that. Our lab is a certified lab. The one in the environmentalist is not necessarily certified. So that's why we'll do
You
ours.
charge a fee for that?
It's $35. Hold on. It's $36 plus $10 shipping for the E. coli test. Because we have the next day. You have 30 hours. And if you do the W35, the E. coli test, I recommend bring it to me about 3 o'clock. Don't pull it before like 2:30, because you got 30 hours. And UPS sort of drops the ball sometimes. It gets lost in the shuffle, and that'll put you another day behind. So if you want to do that, and the W1's not so time sensitive, but you need to do that at the beginning, at the earliest, in the morning time.
Okay.
To do that one. And that's it for me.
Oh, okay. Taking back in the ring rings. Well, I know that we are, thank you, actually. I wanted to make sure, certainly to focus on the soil testing, because that can be really beneficial in the application of ring guards. We're gonna talk a little bit about that. I know we are running up on time. We got started a little bit later, just letting people trickle in. You are not gonna offend me if you've got somewhere else you gotta go, and be happy to send slides. But I am gonna move through this next little bit a little quickly, but if you've got more detailed questions, I don't have any review this afternoon, so we can have a little bit more of a detailed conversation. So, yeah, it's really important to know a little bit about the soils, and then also to know about the quantity of water. So most of the time people are looking to treat water off of their rooftop, because that's the biggest impervious surface they've got in the lawn. So some really basic math about your rooftop, and if you've got a house, a drawing of your home, you can get that square footage pretty easily from a piece of paper. You can also just kind of walk that and get a really good estimate. Google Earth is also a really useful tool. So once you have a little bit of information about your soils and the surface area, that impervious coverage, you can do a pretty basic calculation, or utilize that chart that's at the top to figure out how big the rain garden needs to be. Because you don't need one the same size as your house, thankfully. You can treat the stuff coming off your house in a much, much smaller area. And if you want to get really fancy, I mentioned early on, I'm an engineer, so I do circles, I do squares, I do rectangles. Those are my favorite shapes. But lots of our landscape architect friends want like kidney shape or something that's a little bit more aligned with your landscape. We actually have a great resource for kind of those sample dimensions to make it a little bit more integrated. But one of the things that's really important about the soils is directly connected to that sizing piece, because if you have sandier soils, you can have a much smaller footprint of a rain garden. If you have the presence of clay, which may not be a clay soil, but if you have some of that mixed in, it's going to take longer for that water to make its way back in, and it may be a little bit bigger and shallower footprint. All of our rain gardens are only about 9 inches deep, max of 12, and the best part is you can utilize the native soils. If you do end up being a little bit more on the clayey side, or if you run the soil test and that's what Aubry tells you that you've got, then you want to maybe add a little bit of that sandy mixture to make sure that they're infiltrating a little bit better. This is what it looks like from the side. We're actually routing water in. Oftentimes folks want to use this kind of on the side of the landscape, but it is going to be, again, that bowl. I tell people that there is not a preference in belly buttons, but rain gardens, we want innies, not outies, because if it's mounded, there's nowhere for that water to actually sit. That's sort of what it looks like from the side perspective. And then the piece that most everybody loves to talk about is actually the part that makes it pretty, which are the plants. And I'm going to move through some of these slides. I was very fortunate when we were creating this resource, the book that you've got. My colleague Karen Giovango happens to be a native plant specialist. She is an ecologist and has done a lot of extensive studying. She's the one that developed these resources. Much of the slide material I'm also swiping from her. Happy to give you her contact information as well. But as I mentioned pretty early on, all of the plants that were recommended in this guide and that we would point you to are what we call native plants. So there are plants that are used to our conditions. They're used to the flooding that we experience. They're used to the drought that we experience. Over time, they are much more adapted to where we are. So that's why it's important. If you look in some of these, in the back here, these resources, there are some pretty extensive charts, like the one that I have shown, as well as some photographs. So actually I have the photographs of the grasses there, and you'll see in each of the pictures that she has, she also labels the page number for where it is in the chart. They're pretty well cross-referenced, which is really, really helpful. So as you're starting to dive into those, and if you pull one of these out and you can see this in not so microscopic detail on the screen, it points to things like, is this in a sunny spot? What is your soil condition? Is it in a particular zone? And we'll talk about zones in just a minute. Is it salt tolerant? What's its bloom time? How big is it going to be? All sorts of characteristics when you're starting to think about the plants. And if you love to garden, this is just a fantastic resource in general. I'm going to briefly kind of touch on that because I mentioned it's a bowl. There's these different zones. Obviously in the bottom of it, just like in your bathtub at home, that's going to stay wet the longest. So we need to be able to pick a plant that really likes that space. So my absolute hands down favorite native plant is actually this one here on the top left, the kernel flower. It likes wet feet. And so it's going to show up in that zone 1. Whereas the orange coneflower, the one on the top right, it's kind of happy anywhere. It'll most of the time it'll make it in the wet, but it's also really happy to be in zone 3, that outside drier area. A plant like the Indian wood oats, the one here on the bottom left, it favors a little bit more shade. Also, there's a collection of ferns and grasses that are like that. So if you have a little bit more of a shady spot, those are the ones you're looking for. And then also thinking about how big they're going to get. Like the American Beautyberry, which is that one on the bottom right, it's gorgeous. It has these really pretty purple berries on it, but that's not going to be 8 feet tall. So when you think about it, you certainly don't want to put that like right at the very front of a rain garden. And then lastly, kind of moving through this, thinking about how do we get it in the ground. And sometimes this is one of the bigger hurdles for folks. I always encourage, make it a fun event because there is some digging involved to get to that depression. So invite community members, family, whatever, crew, to help you get it laid out and really get to that, to hit that process. Like I said, moving through pretty quickly, but one of the things as we kind of wrap up, I mentioned early on, there is an effort to move some of these practices on a larger scale within the community, and you're going to start to see some of those show up. But as we're thinking about resources for that, also what sort of resources, if any, that you'd like to see on a residential front. And so just a couple of ideas to whet your appetite. Love to hear a little bit more. But as Mr. Key mentioned, rain barrels are actually pretty affordable in this part of the world and easy to get a hold of. That's not true everywhere in Georgia. But one particular option would be to have a workshop or a resource to pull all that together if there's folks that are interested in rain garden harvesting. Another example that I would point you to, or an idea to think about, hopefully there are pieces today that you'll be able to take and actually implement in your landscape. But that's not true for everybody to have access to those resources. This is actually referencing a project that came out of the development of some of these resources, but a neighborhood in Glenn County closer to me, lots of folks didn't have the financial means to make rain gardens happen. And so looking at incentive programs and how you can help a neighbor out, many of the folks that were participating in this were concerned about their neighbors along their street because lots of flooding along the area. And so this was a pilot program. There was some grant funding secured to support paying for the plants that they were using, helping assist them with design, as well as helping them get those things in the ground. And excitingly enough, they actually were able to really do that without the assistance of the grant. But it's just a really a great success story in my mind that I would point you to. We had 6 residents in the neighborhood. They currently manage close to 220,000 gallons of water a year. Itty bitty little rain gardens. And one of the things that's very powerful and informing, or powerful to their message, is the city of Brunswick actually has a stormwater utility, so they have to pay a fee every year to help offset some of those infrastructure costs. And because of this implementation, they're able to get a reduction in that fee for their property on a 5-year return. And so a lot of this conversation, I get questions all the time, well, what's a rain garden gonna actually do? And in the large scheme of things, it's just like those little squishy balls back there. It's a drop in the bucket. But every little drop that we can keep out of the larger system, every little drop that everybody is contributing, all the drops add up when we think about, this is 217,000 gallons is a sizable amount. It's about 50 Olympics swimming pools, actually. So, moving really quickly through the end part, and want to point you to some resources because I know that we're well over time. One of the things that we produce that kind of aligns well with this guide is a form that helps you step through some of that information in your own yard. And not everybody is as comfortable as some, but being able to have a sketch to think about it. And so this is a useful tool. If you're like me, I like to use a pencil on a regular basis, but inevitably I screw this up. So it's easily downloadable. You can have access to resources. I hope that you all picked up a guide that, like I said, has a lot more detail for the things that we kind of blew through earlier. But along those same lines, I'm not going to hold us because we are over time, but there are some paper copies, and then you can also use this giant QR code in the slides. But 4 or 5 questions. What are some of the things that you're interested in? If there's feedback that you have with regard to workshop content, but if you don't mind filling out that evaluation, it should take you probably less than 3 minutes. That would be really helpful for us moving forward. With that, like I said, I appreciate you hanging around. We got started a little bit late. Here are some of the resources from Marine Extension Georgia Sea Grant. All of these resources are available online. So if you've got a friend that you want to point them to, I know Aubry's got cards in the back, other resources. Like I said, I'm not looking to zip out of here, so if you've got specific questions, but I know other folks have got things to do, so.
I have a question,
Yes, ma'am.
and it's probably not relative to, what is a rainwater utility?
some have specific to actual rainwater, but a lot of them fall under a broader umbrella of a stormwater utility. So talk about that one first. That is where there's a policy in place at the local jurisdiction. Let me back up. So our water infrastructure, so all water piping and that sort of thing, and our wastewater infrastructure, particularly within a city limits, is all part of a network. So your water and your sewer is taken care of, and you're actually, most municipalities have that built into your tax bill. All of the flood water and the associated infrastructure, whether it be pipe or ditches, anything that's used to maintain that network, there's not a funding source. So some municipalities have said, okay, you've got X amount of impervious cover, you're contributing X amount based off your property, and so they add a fee to help build a fund to handle the challenges of flooding and water quality. Reidsville does not have one. Matter of fact, a lot of the places here don't have one. Now, there's kind of a catch-22 for that, at least from my perspective. If you have those funds and you're building those capital dollars, then you can put a little bit more pressure on elected officials to address those issues, because there's a fund and we have resources and staff that can go after it. If there's not funding, you have to rely on the approval of those capital funds or grant dollars or other sources to address a major problem when it comes to stormwater flooding. And so here, it's nice, it's maybe not the best word, but you don't have that repetitive fee, but you also don't have that dedicated funding source to address those challenges.
I'd like to see Brunswick find it more urgent because they're lower.
Yep. As far as places around that have one, off the top of my head, Brunswick just adopted theirs a couple years back, and it was pretty contentious. But one of the things about Brunswick is there's a lot of industry, so the hospital, the ports, and others, they contribute a lot of stormwater runoff, but at that point in time, they were not contributing to the management of it. And so through the utility, everybody is putting money into the pot, so to speak. Garden City is another one that's kind of, I'm trying to think, Savannah, different part, not City of Savannah, but yeah, different parts in Chatham have one. Out this way, I'm trying to think of the nearest, I think Macon has one, but not much in between. They're not very common, particularly in rural areas, just because there's lots of other things that take priority over it, but yeah. Specifically with the rainwater piece, we see it mostly under the larger stormwater utility umbrella in the southeast. Further west, they get in more the rainwater piece.
Did Atlanta ever finish, weren't they doing some wastewater, like runoff stuff a long time ago?
Yeah, there's a lot of utilities up in that area.
I heard they were building, this was some years ago, I thought they were building like a whole catchment to slowly treat their wastewater, the runoff, not the wastewater.
Yeah,
Okay.
yeah. So there's a lot of larger scale practices. So
Okay.
you may be thinking about they use a lot of underground detention
That's what
for storage.
that's what they were doing.
That's a potential solution.
Okay.
And like I said, the larger effort's going to consider things like constructed stormwater wetlands or stormwater parks, stormwater ponds,
Reserves.
ways to regionally collect it. Yeah.
As I Googled, and Atlanta has, a lot of them, going on up to Marietta,
Mm-hmm.
and
Oh, yeah.
they've encompassed parks with them and the water flows. And one of the reviews stated that when it rains a lot, they still have problems with the soil, coming across the walks, and trees falling, small trees.
Yeah. Yeah, but oftentimes it is linked up to a park because that provides that active
Extra
green space. You're looking at recreation, and one of the larger scale solutions proposed as part of that work is to look at, okay, well, how can we alleviate that flooding in a large area by using a stormwater pond, but also create space for people to recreate, lots of that tree impact will take care of providing shade and heat island offsets and lots of other co-benefits. But yeah, there's a lot of parks activity associated with stormwater because it's got to go somewhere.
Then I have one other question, I'm gonna be quiet. You know how, in landscaping, you see a lot of people put these little rocks. Is that a good thing or a bad thing? Long term? Bad.
I don't know, if you put a lot of rocks, I feel like it'd be hard to grow something.
Well, they're doing it to keep the weeds out, you know?
Yeah.
And they put down the
You mean like the small pillars or the big pillars?
small ones.
I used to keep dirt from coming in my house. I used to
Okay.
walk around, we used to go through roads.
Yeah.
Yeah, you could do that, and because it would slow like the bigger surface of the rock, it would slow the water down, so big riprap. I'm not sure how that much, but.
No, I don't have it, I was just thinking in terms of, keeping the weeds.
Yes,
You can do that, I mean,
you see it a lot in edging with rain gardens or like in the entrance where you might have some of that erosion. One of the challenges though is really paying attention to size, because if you get these teeny tiny little bitties, like the person that owns my house before, they did not know much about this, but direct all the water to it. Those little ones, they'll get up and float and they'll run away. And so then you spend all your time chasing all the little itty bitty rocks, which makes it a little bit more difficult. So if you do have a lot of water directed, I would say make sure to look to some of the larger sizing, like the river stone. It doesn't have to be like huge riprap, but
Yeah.
just this, because then you're not going to be chasing it all over in your yard.
you'll still have weeds though.
But yeah, it certainly helps
Well, I
with
won't
weeds.
do it.
Help slow down, and it can be really helpful if you've got areas that have a steep slope, like you were talking about before. It can help slow the water down and make sure it's not taking soil with it. Not as pretty as some of things. Yeah, definitely helpful.
But a retainment wall wouldn't help her slope, or, no, it depends.
So a retainment wall is a viable solution in a lot of situations. And a lot of times folks will ask, well, why use plants and soils and rock and stuff like this when I can just build a structure? You can build a structure and it'll be great. The challenge with that is if water gets behind that structure, or if you get floodwaters that come up, then instead of having this small landscape area that's actually going to get drained down, you're going to be stuck in a big hole of water behind the repayment wall or whatever
Should have
structure.
another
So, right. So, lots of folks are, if you design it big enough, strong enough, then yeah, you might be fine. But on the off chance that we get one of those crazy storm systems, you may actually have locked yourself into water. And so one of the reasons that folks are really interested more so in some of those natural-based systems is they have the ability to flex and adapt versus some of our more hardened structures. Sometimes you can't get around it, like I love concrete just as much as the next girl, but yeah, sometimes there's nothing better than just having the pipe, but whenever we can use some of those other softer things, it sometimes allows you to prevent a future problem. Thank y'all so much. Please get a snack, and like I said, if you've got other questions, hang around, but I don't want to keep anybody unnecessarily. Please take advantage of the resources that Aubry mentioned to you. If you want a paper copy of the form, I would really appreciate it if you would fill one of those out. Or